the Friday Shoes production. Our target today, I can divide monomials. The inverse operation of I can multiply monomials, which we talked about yesterday. Follow us along on page 550 in the textbook. Remember, fraction bar means divide. That means you take the top, the numerator, and divide by the bottom, the denominator. Notice in our example, they have the monomial 5 to the 7th power all over 5 to the 4th power, which means divide those. More so, they actually show you the long way of breaking these into factors. Notice the top, they have 7 5s being multiplied together. And on the bottom, they have 4 5s written. What's nice is, if you remember, if you take the top and divide by the bottom, if the numbers are the same, you can cancel them down to 1. So what they're showing you here is 5 over 5 actually equals 1, so we can get rid of it. 5 over 5 equals 1, 5 over 5 equals 1, 5 over 5 equals 1, and you're left with just 5 times 5 times 5, which is 5 to the 3rd power. All over 1, but that equals 5 to the 3rd power. Keep that concept in mind as we go through the quotient of powers key concept. Simply, to divide powers with the same base, we subtract their exponents. If you remember yesterday, we actually talked about 3 to the 7th power times 3 to the 3rd power equaling 3 to the 10th power, where we added these exponents when the bases are the same and we're multiplying. Well, now take a look. When we are dividing, we are subtracting. Top exponent minus bottom exponent. Final answer will be 3 to the 4th in this case. And if you look at the algebra, it's the same way. If the bases are the same, the a's, then all you do is take your top exponent minus the bottom exponent, and your answer will be a to the m minus n, whatever that would be. One thing you got to be careful is a cannot be 0. So this works for all numbers except for 0 as a. Follow with me, let's do a couple of these examples. 4 to the 8th power all over 4 to the 2nd power. Simplify, express using exponents. So they want us to write as exponents. Well, if you remember, 4 to the 8th over 4 to the 2nd from the quotients of powers, that just means you take the top minus the bottom exponent. You can write it as one base of 4. So 4 to the 8 minus 2, which would equal, of course, 4 to the 6th power. We can do that, of course, because the common base is 4. The bases weren't the same. We couldn't do this. Take a look at the second one. N to the 9th power over n to the 4th power. Again, the bases are the same. Therefore, we can subtract the exponents. Top minus bottom, 9 minus 4. That will give us a simple n to the 5th power. That's your final answer. Why don't you try 3 of them? Go ahead and pause the video. Try these in your notes. I'll do them right now. 5 to the 7th power over 5 to the 4th power, written as one exponent, or one power, would be, if you take, and notice that your 5s are the same, those are your bases, then all you have to do is take 7 minus 4 to get how many 5s you're going to have repeated. So it's going to be 5 to the 3rd power. There's your final answer. Second one, same thing. X, the bases are the same, they're x. So you have to just subtract the top exponent minus the bottom exponent and write it on one of the x's. So we have x to the 7th power. Last one, they throw something new at you here. They throw coefficients into the problem. Well, simply what I would do is I notice I have 12 over 2, but I also have w to the 5th over w. I'm going to break it into 2 math problems. What's nice is when you do this, all you're really doing is splitting out multiplication. And notice I put a 1 in the exponent for the w, so it'd be easier for me to subtract. Once I've broken it out into this, I show that 12 divided by 2, or 12 over 2, is equal to 6. That's just going to be multiplied by whatever w to the 5th power over w to the 1st power is, which is w to the 4th. All I'm really doing is subtracting these numbers. There's my final answer, 6 times w to the 4th. What about using negative exponents? Well, don't let those scare you. All you do is follow the same rules. If the bases are the same, you subtract the exponents, top minus bottom. So if you look, they still have the base the same, that's 6. So let's write it as 6 to the 9 minus negative 3. And if you remember, two negatives when put together make a positive. So in the end, our answer is 6 to the 12th power, which is just 9 plus 3. That's your final answer. How about number 4? If you look at this one, it's the same thing. It just has two negative exponents. Don't let that scare you. Again, it's just the top minus the bottom. The bases are the same, so we can do this, meaning we can take the negative 1 from the top and subtract off negative 4 from the bottom. When we do that, you might recall, again, two negatives right next to each other like this will make an addition problem. So we have w to the negative 1 plus 4, which of course is 3. I know some of you still struggle with those negatives and positives. Keep practicing, you'll get better at it. Go ahead, stop the video, and you can try these 3. Come back and see if you got them right. I'm going to do them right here. Simplify, express using positive exponents. Well, I noticed that the bases are the same, so I'll write it as one base, and then take negative 8 and minus 2. Again, you're subtracting top minus bottom. I can do that in my head. Negative 8 minus 2 more is going to be negative 10. Now it says express using positive exponents. Positive exponents. This is not a positive exponent. That says 11 to the negative 10 power. Again, from yesterday's lesson, if you remember, 11 to the negative 10 power is the same as the reciprocal of 11 to the 10th power, which is 1 over 11 to the 10th power. There is your final answer. No more negative exponents? How about E? Same rule applied. Notice that B is the common base. So let's take the top and subtract the bottom exponent. When we do that, here's the math problem that we end up doing because two negatives make a positive when they're put together like this. Negative 4 plus 7, excuse the bell, is b to the 3rd power. There's your final answer. It is a positive exponent, so I don't need to do anything with it. F, the last one. Notice again we have coefficients, so we're going to deal with that separately. We'll pull those together, put a multiplication between it, and we'll pull the other ones together. We have h to the 5th all over h to the negative 5th power. Well, 6 over 3 is 6 divided by 3, which is 2. We're going to multiply that by whatever we get over here, where we're going to take the 5 and subtract the negative 5. H's are the same, that's the same base, so therefore we take 5 and subtract negative 5. When we do 5 minus negative 5, again, that's going to come out to be a positive or an addition problem, so it's 5 plus 5. That's 10. There's your final answer, 2 times h to the 10th power. And the last example. This is a testing example. You can see they have choices at the bottom, A, B, C, and D. You've got 2 to the 2nd power times 4 to the 5th power times 5 to the 2nd power, over 2 to the 5th power times 4 to the 4th power times 5 to the 2nd power. Break it into 3 simple math problems. I notice that the bases are the same on those first 2, top and bottom. Break it off to the side. You can do this legally, meaning you can put a dot in between these and everything will stay the same. And then let's attack it as individual problems here. Well, let's start with this first part here. 2 to the 2nd power over 2 to the 5th power. I've been told to take the top minus the bottom, so that's going to be 2 to the 2 minus 5 power, which is 2 to the negative 3rd power. Also, next will be 4 to the 5th all over 4 to the 4th. Well, that's going to be 4 to the 5 minus 4, which is 4 to the 1st power. Then we take that last one, and we multiply, or take 5 to the 2nd power over 5 to the 2nd power, which is 5 to the 2nd minus the 2nd. So it's going to be 5 to the 2 minus the 2. Well, wait a minute. That's going to be 5 to the 0 power. Now let's discuss these 3. I'm going to move this over to the top here. So we have 2 to the negative 3rd power times 4 to the first power times 5 to the 0 power. Remember that 2 to the negative third power is 1 over 2 to the third power. Also remember 4 to the first power is actually just 4. And here's an old one, 5 to the 0 power. We memorized that a while ago. Any number to the 0 power other than 0 is 1. So 5 to the 0 power actually equals 1. Don't believe me? Check it on your calculator. Now multiply these together. Well, wait a minute. I've got this 2 to the third power I got to deal with. That is 1 over, well, what is 2 to the third power? 2 times 2 times 2. That's 8. So I got 1/8 times 4 times 1. When I multiply all this together, I actually end up with 4/8, reduced down to 1/2. How did I do that? I multiplied the tops. I changed these into fractions. I took 1 times 4 times 1, put that there, and I took 8 times 1 times 1 and put that there. And I ended up with the reduction down to 1/2. So the answer is C. Don't forget, you can always review this video, read any examples in the book, or try some of the personal tutor videos on the online textbook. And as always, this has been a Friday Shoes production.